This is an AS statistics question about the large data set. Helen believes that the random variable C representing cloud cover from the large data set can be modeled by a discrete uniform distribution. Part A, we need to write down the probability distribution for C. Now, probability distribution is basically like a table of probabilities where the top row is going to be the outcomes, which is going to be C, and the bottom row is going to be the probability of each of those outcomes happening. Now, before we can do that, we need to understand how we represent the cloud cover from the large data set. So first of all, the amount of cloud cover is measured in octas, and octas represent the fraction of the celestial dome. That's all the sky that can be seen from one horizon right round to the other horizon. So think of it like a big massive semicircle, or hemisphere would be better way of describing it. And it goes from 0, which means that the sky is completely clear, to 8, which means that the sky is completely overcast. So assuming that we've got an equal chance of the cloud cover being any one of these octa numbers measured from 0 to 8, when we draw our probability distribution, we've been told to use the letter C for cloud cover. So on the top, we're going to go from 0 to 8. So we'll have 0, 1, 2, 3, 4, 5, 6, 7, 8. Then on the bottom row of our table, we'll have the probability of the cloud cover being any one of those amounts. And assuming that we've got an equal chance of any one of those, they're all going to be 1/9. So we'll put that in on the bottom row of the table. So every single one, let's do this a different color. So 1/9 for each of the outcomes, because there are 9 outcomes here, not 8, 9, because we're going from 0. Okay, we can move on to part B, and it says, using this model, find the probability that the cloud cover is less than 50%. So less than 50%, we're going to have a look at which columns that includes. So 1/9, 2/9, 3/9, 4/9. Now when we get to 5/9, that's more than 50%. So we want these probabilities here. So I could write down that actually I've got the probability of C. Let's get the right color. You can't see that in yellow. Probability that C is less than or equal to 3, or you could write it as the probability that C is less than 4. In either case, that's going to be 1, 2, 3, 4/9 for the probability that the cloud cover is going to be less than 50%. Helen used all the data from the large data set for Hern in 2015 and found that the proportion of days with cloud cover less than 50% was 0.315. Part C, comment on the suitability of Helen's model in light of this information. Well, first of all, from part A, we have the probability that the cloud cover is less than 50% is this 4/9, which is actually 0.4 recurring. Well, this is higher than the 0.315 that she got by looking at all of the days for Hern in 2015. In fact, it's about 41% higher. Therefore, the uniform model from part A is not a good one. And lastly, part D suggests an appropriate refinement to Helen's model. So one possible refinement to Helen's model is to use a non-uniform model. So an example might be a binomial distribution that's non-uniform, where the probabilities of the different amounts of cloud cover can be calculated by recording data from different locations and different times. Helen only took data from one location, Herne, at one time 2015. So we want to extend that so that we can work out what these probabilities actually are, or at least get the relative frequencies, and then work out the probabilities, get a better idea of the distribution, and then get a better model rather than this uniform distribution here.